An isosceles triangle is a triangle where at least two sides are equal length. So if I have a triangle, I need at least two of the sides to be the same. The legs are the equal sides. The base is the third side. The base angles are the angles opposite the equal sides of an isosceles triangle. So here are the equal sides. Opposite goes across into the corner. Opposite goes across into the corner. And here are your base angles. Well, it doesn't. It's not necessarily, because if my triangle is like this and these are my equal legs, then this is the base. So the base is the non-equal side, okay. And then the base angles touch the base.
You should write that by base, non-equal side.
Well, it's okay. The vertex says it's the angle opposite the base. You can also think of it as the angle between the two equal sides. Which are the legs. So if I have my triangle, here's my two equal sides. This is my vertex. A nice picture of what I was talking about. So the vertex falls between the two legs. The base is the non-equal side, and then the base angles touch the base. And that by definition, they are across from the congruent legs. The yellow doesn't really show up. The green is?
If you do the thick green, it's okay. There you go. So are you liking this one much better than the other?
Okay, the vertex is between the equal sides. Some isosceles triangle theorems. Okay, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So basically what this means is the base angles in an isosceles are congruent. Okay, so if I have an isosceles triangle, I have two legs that are congruent, then that means that the base angles are also congruent. When two legs are congruent, it's isosceles. Yeah. Then we can go backwards, and this tells me that if two angles in a triangle are congruent, then it's isosceles. Okay, so one way we have, if you have an isosceles, your base angles are congruent. And the other way is if we have angles that are congruent, two of them, then that means that the legs are congruent. Okay, so here congruent legs equals congruent base angles. And here congruent base angles equals congruent legs. So it goes back and forth basically. Polygons. In the last unit we talked about if you're a regular polygon, you're equiangular and equilateral. Well, if you're a triangle, if you have 3 equal angles, you have to have 3 equal sides. And if you have 3 equal sides, you have to have 3 equal angles. There's no other way that that can work. You can't have equal angles and non-equal sides. So what you get is an equilateral triangle. And that's what we call it, is an equilateral triangle. Okay, you don't really talk about an equiangular triangle because quite honestly, it's easier to say equilateral than equiangular. Okay, so the triangle name is equilateral. Equilateral triangles have equal angles and equal sides, and every angle is 60 degrees. Which, as you think about, that makes sense because a triangle is 180, and if you have 3 angles that are all the same, you divide 180 by 3, and you get 60. Can't be anything else. Okay, so these 3 all deal with equilateral triangles. Okay, so this is equilateral triangle world. And then we have another isosceles triangle property which says the bisector of the vertex is the perpendicular bisect of the base. So what that tells me is if I have an isosceles triangle and I come in and I cut this angle in half, which I just did not even do. Won't let me. It won't look. See. Okay. Well, we're going to pretend that that cut the angle in half. Okay. So if actually, I'm going to change the color of that line. So this red line here cuts the angle in half. Okay. So we have this angle is the same as this angle. This is the angle bisector. Okay, and we're talking about for our vertex angle, so that means these 2 legs are the same length. Then what happens is we get a perpendicular line to the base, and these 2 lengths are the same. So the angle bisector is also the perpendicular bisector of the base. And that has to be the vertex angle. So if you cut the vertex angle in half, you also cut the base in half. How do we use this? Well, this right here tells me that this angle and this angle will be the same. So I know that this angle is 50. So if I take the triangle, which is 180, and I take 50 away from it, there's 130 left. And then there's 2 equal angles. So I take that 130 and I divide it by 2. And I get 65, so that's what x equals, 65. These 2 angles being the same, that tells me that these 2 sides are the same, here and here, which tells me that x is 5. these legs being the same and these legs being the same tell me that these angles are the same and these angles are the same. So all four of those angles are the same. Does that make sense? Now this is 86. So if I know that that's the non-equal angle, I'm going to take 180, subtract 86 from it, which will give me 94.
Divided by
2.
or
2, because we're still inside of a triangle. So
oh, I guess,
we're looking for these two. So divide it by 2, and that gives me 47. So this one is 47. So this one is 47. All four of those are then 47. So x equals 47.
Wait, can I switch with my eyes later?
Take it apart then. Take it apart if you need to. Okay. These three sides all being the same tell me that the three angles are all the same, and it's an equilateral triangle. And if it's an equilateral triangle, the angle is always 60. But if you didn't remember that, yeah, it would be 180 divided by 3. Again, all three angles being the same means that each angle inside is 60.
And then you have to subtract it by 180
To find x, exactly. 180 minus 60 will give me the 120, and that's what x equals. Okay, we do not have angle side side, but you can have angle angle side. Okay, so this is angle angle side. Okay. So if I have two triangles, copy it. With that, I can have one angle, two angles, and then this side. Or I could even go the other direction, and I could have like this and this side. Okay, so two angles with the following side, going either clockwise or counterclockwise around the triangle, it doesn't matter. So it's two angles and the non-included side. So the side next to them, not between. If it's between, of course, it's angle side angle. Is for right triangles only. So remember, in a right triangle, we have a right angle, and the side across from the right angle, so the point of the right angle points to the side across from it, that's the hypotenuse. Okay, hypotenuse, across from the right angle. And then this is just a leg, and this is just a leg.
The base was long one.
Now we're talking about in a right triangle, these two are interchangeable, but this is the hypotenuse, it's special.
Oh, so strictly when it's a right triangle?
Yeah, strictly when it's a right triangle. And the hypotenuse is always across from the right angle. So we have the hypotenuse leg theorem. This is HL is hypotenuse leg. Okay, and what that tells me is if I have two right triangles, and the hypotenuses are congruent, and either leg. So I can have this one, or I could have the other one. Okay, so I have to have the hypotenuse, and I can have either of the other leg, and this is only in a right triangle. And now you might notice this is an angle side-side situation, almost. But because it's a right triangle is the only reason it works. Because right triangles are restricted by Pythagorean theorem, which tells me if I know this length and this length, I can find this length. So basically, it's really a side, side, side. Okay, so if you have the hypotenuse, this is the important, you have to have the hypotenuse and either leg. Hypotenuse angle, which is basically the same thing as hypotenuse leg, only it's the hypotenuse and one of the angles that's not the right angle. So hypotenuse angle. And so if I have a right triangle, oops, right triangle, right triangle. So I have the hypotenuse and this angle, or it's not cooperating. I can have the hypotenuse and this angle. Okay. This kind of also falls under the angle side thing. So with hypotenuse leg, back here you have to use hypotenuse leg because there's no angle side. So you have to have hypotenuse leg. With hypotenuse angle, you can use either hypotenuse angle or angle side and be correct.
So wait, this one I finished writing it.
Okay.
Right when you said it.
All right. So here we have some examples. As we move around the triangle, I have angle, side. So that's angle, side. And here, across from my right angle are my hypotenuse, and they match. And then I have another side. So this is hypotenuse leg. And then here I have, again, across from my right angles. So those are hypotenuse. And then an angle. So this is hypotenuse angle.
Okay, wait. What the L means what again?
Leg.
Leg.
Yeah, hypotenuse leg.
Right.
Here's the hypotenuse, and then each of these are legs.
Yeah, but why does the other one have the same?
Here,
Yeah.
because I have an angle
Oh, I didn't see
instead
that
of the
one.
leg. Yeah. So you always want to look across from the right angle first, and then see if you have another leg or an angle. But you have to make sure these match first. If those don't match, it's going to be something else completely or not at all. Again, across from the right angle, these are hypotenuse. So I have the hypotenuse and I have angles. Hypotenuse angles.